Today we are going to start with the 30-day, that is the progressive practice plan of that is starting from the school basics to the IIT foundation level. So this will be the day 1. So here you will have the practice 12 questions here. So this is the first question here. Prime factorize 360. So here how to factorize 360. So whenever this is for the factorization, this is the prime factorization, we have to always start with 2. So 2 ones are, so remaining is 1, 2 eights are, and here this is 0. Again this will go with 2, 2 90s are, then 2 45s are. So now this is 45 is not possible with 2, so we'll go with 3, 3 15s are, 3 5s are. Now this 5 will only go with 5. So these are the factors of 360. So we can write here 360 will be 2 3 times, 3 2 times, and this is 5. So we can write this as 2 cube into 3 square into 5. Now let us see the next question. Find HCF and LCM of 36 and 120. So here 36 and 120. So now we'll take the prime factors of 36. So 2 18s are. Again these 2 9s are. So this is not possible with 2. So we'll go for 3 3s are and 3 1s are. For 120, again here 2 60s are, 2 30s are, 2 15s are. So this is not possible with 3. With 2. So 3 5s are, and this will be 5 1s are. So now what will you do? 36, the factors of 36 are this one. So we'll write here in this, the horizontal way. Again for this, the factors of 120 is, these all are the factors we write in the horizontal way. So why are we writing like this? Because now first thing you know, LCM means we take the common first and then the uncommon. So in this both, these are the common ones. So these are the common ones. And now what is remaining? These are the uncommon. So these are the uncommon. So now while multiplying, you are going to multiply this all. So that is going to be 360. And now we have to find out the HCF as well. So for HCF means we just take the common factors. So HCF will be 2 into 2 into this 3, which is going to be 12. Now let us see the third one, that is find HCF of 462 and 1071 using Euclidean this algorithm by this one, and then compute the LCM. So now, so by this one, by Euclidean algorithm means we have to do 1071, we are going to divide it by 462. So 462 2s are 924. So the remainder is 147. So this 147 again you are going to, this one 462 divided by 147. So that will be 147 multiplied by 3, that is going to be 441. So the remainder is 21. So this 21, so this 140, so we are going to look for this one. See here, this is, you know, this is the dividend, this is the divisor, this is the quotient, and this is the remainder. So always we are going to see for the divisor part. So this will be again this, and this will be 147 divided by 21. So 21 7s are, this will be 147. Till we get the remainder 0, we have to keep on dividing. So now you have to see the last divisor. So for this one, because here you got 0, so you have to stop at this stage. So the last divisor is 21. So we can say HCF of 462 and 1071, that is going to be 21. The fourth one, what is the smallest positive integer divisible by 2, 3, 4, 5, and 6? So now here, sorry, here the one more thing is left. We have to find out the LCM as well. We found out the HCF using the Euclidean algorithm, and now we have to find out the LCM. So the LCM here for 36, So if the HCF we got as 21. So to find out the LCM, we'll use this formula, product of two numbers, that is LCM into HCF. So product of two numbers means these are the two numbers, 462 and 1071. We don't know what is the LCM, but we got the HCF as 21. So here this will be same, this will be on the left hand side. So this will go on the from the right to the left. So this will get divided, is equal to LCM. So 21, this one ones are, and this will be 22. And when you multiply this, you get this as LCM is 23562. So now the next one, smallest positive integer divisible by 2, 3, 4, 5, and 6. So for the 2, the factors will be just 2. For 3 will be just 3. For 4, the factors will be 2 into 2, which will be 2 square. For 5 is just 5. And for 6, the factors will be 2 into 3. So to find LCM, we have to take the highest power of each prime factor. So now we have to see for this one, the highest power was 2 raised to 2. Here will be just 3. And here will be 5. So here for 2, we just have, when we compare this 2, we have the highest power is 2. So we have taken this 2. For 3, there is just 3. And for 5 is just 5. Hope this is clear. So you have to remember this one. To find LCM, take highest power of each prime factor. These are the prime factors. So this will be 4 into 3 into 5, which is going to be 60. So we can say, therefore, smallest positive integer divisible by 2, 3, 4, 5, and 6 is 60. So the next question is, we have is 279 divisible by 3, and then it is divisible by 9, and you have to explain here. So here, first for 279, so what we have to do, we have to take the sum of digits of 279. So 2 plus 7 plus 9, that is going to be 18. So divisible by 3, yes, because 18 is divisible by 3 because the remainder is 0. Divisible by 9, yes, because here 18 is divisible by this one, 18 by 9, that will be 9 to the 18. So that will be, the remainder is 0. So both of them is yes. Check whether 4729 is divisible by 11. So for 4729, a number is divisible. This is the rule for that. A number is divisible by 11 if the difference between the sum of the digits of that is the odd places, and the sum of the digits at the even places, it should be either 0 or a multiple of 11. So this is the rule for the divisibility of 11. So now the odd places, now see here, this is the number. So this is 1, 2, 3, 4. So which are the odd places? Because 1 and 3 is an odd number, so 4 and 2 is a odd places, and 2 and 4, these are the even numbers. So 7 and 9 will be the even places. So we'll see for the sum of the odd places, that is 4 plus 2, that is going to be 6, and sum of the even place digits, so this is 7 and 9, which is going to be 16. So when you subtract, for the finding out the difference, you have to subtract the sum of the even place digits from the sum of the odd places. So whenever this word from is used, after that, whatever is there, the number should be at the start. So after from, what is that? The sum of the odd place digits. So this is also one of the important thing what you have to remember. So here will be 6 minus 16. So this is going to be minus 16 plus 6, which will be minus 10. So see here again, the difference is going to be subtract the sum of the even place digits from the sum of the odd place digit. So after from, what is that? The odd place. So you will take 6 at the start and then 16. So minus 10 is not a multiple of 11. So we can say 4729 is not divisible by 11. So you have to find the LCM of 8, 9 and 21. So LCM of 8, 9 and 21. So you can also do this way. So now we'll be starting from 2 to 4s are. So 9 is not divisible by 2. So we'll keep as it is, 21 also as it is. So again, we'll start with this 2. 2 2s are. Again, 9 and 21 not possible. So again, till this one, 2 1s are 2. So we have to see all the numbers for the 2 first, and then for 3, 4, and so on. So here 2 ones are. So again this 9 and 21 not possible, so write as it is. So now we can see here this is 1. So now this is 9 and this is 21. So this goes with 3. 3 threes are. So you will write this 1 as it is here. Just write here as it is. So here will be 3 threes are and this will be 3 sevens are. Again now this is possible with 3. So 3 ones are and this 7 will be as it is. So now 1 1 and now the 7. So this 7 is just possible with 7. So 1 1 as it is and this will be 7. So now these are all the factors of 7, 9 and 21. So we can say LCM is, this will be 3 times 2 times 3 and this is 7. So when you multiply this all, which comes to 504. So now you have to reduce the fraction 462 divided by 1071 to lowest term. So now let us see how to do that. So now to reduce, what we have to do, we again will take the factors of 462 and this will take the factors of 1071. So factors, this is divisible by 2, 231. So this is not divisible by 2, so it will be 3. So that will be 77. So now this is not by 3, directly with 7, 7 11s are, and this will be possible by 11. Again now this is not divisible by 2, so we will go with 3. 3 357s at 1071 again with 3. So now this is not divisible by 3, so that is by 7. So 7 17s are and this will be 17 ones are. So 462, these are all the factors of it. And for 1071, these are the factors of it. So for this one, whenever we want to reduce the fraction, reduce means you have to take the HCF of it. And you know HCF means we just take the common factors. So now your common is, so why we are writing here one below the other, so it becomes easier to form the groups. So the common is 3 and 7. So 3 and 7 means 3 into 7, which is going to be HCF is 21. So what will you do here? 462, what you have to do? We have to see for the lowest term 462 divided by 1071. So this also you are going to divide by 21 and this also number you are going to divide by 21. So after dividing this one, you get 22. After dividing this, we get 51. So this is the lowest term. So now here we have to find the HCF and LCM of 48 and 180. So you have to find the HCF and LCM of 48 and 180. So now what will you do? First we'll take the factors of it. So factors of 48, 2 24s are, 2 12s are, 2 6s are, 2 3s are and 3 1s are. For 180 that will be 2 90s are, 2 45s are, 3 15s are, 3 5s are and 5 1s are. So these are same thing, these are the factors. For 88 these are the factors of it. For 120 these are the factors of it. So for LCM means we take the common and then the uncommon. So these are the, we have to group it. So these are the common ones. So 2 2 and 3 and then this will be here. These are the uncommon ones. So after multiplying this all, we get that is 720. And HCF, you know that we just take the common. So these are the common 2, 2 and 3. So that will be 12. So now you have to find the smallest positive integer k such that 84 into this k is divisible by 360. So same thing is written over here. So what will you do? We'll take the factors of 84. So 2 42s are, 2 21s are. So this will be by 3 7s are and 7 1s are. Again for 360, 90, 2 45s are, 3 15s are, 3 5s are, and this will be 5 1s are. So same thing is written. These are the factors of 84 and these are the factors for 360. So for this one, to find the smallest positive integer, so what will you take? You will take the common ones, that will be 2 2 and 3. So HCF of this will be 2 2 and 3, which is going to be 12. So now we want to find the smallest positive integer k. So what will you do for k? What will you do? 360 you are going to divide it by 12 which is going to be 30. So K is going to be 30. Now let us see this question. I have already written it down because it takes a long time to scroll it. So here, convert the repeating decimal. This is that 0.363636 to a fraction in the lowest term. So now we'll consider, let x is same thing, 0.363636 and so on. So what will be that? If we take this x is this one, so if we take 100x, so this is multiplied by 100. So same thing, this also should be multiplied by 100. After multiplying by 100, we get 36.36, 36 and so on. So now what will you do? 36x minus this x, that will write here, that will be 36.36 minus this one. And when we subtract this one, 36.36, 36 and all, 0.36. When you subtract this one, we get that will be 36. So here 36 minus x will be 99, x is 36. So x is going to be 36 divided by this. This is multiplication, goes on the other side, that will get divided. So when you simplify this one, 9 4s are, and this will be 9 11s are, which is going to be 4 divided by 11. Now again here the same thing is written here. Two numbers have HCF 6 and LCM is 420. If one number is 18, you have to find the other number. So now what will we do? We found the two numbers. So we will take, let A and B be two numbers. So the product of two numbers, this formula you have to remember, that is the HCF into LCM. So now the two numbers we have considered A and B. So A into B, that is given here. One number is given as, here is given as 6 and the LCM is given as 420. So this is here, if one number is 18, the other one we don't know. So that is 6 into 420. So B will be 6 into 420 divided by 18, which is going to be here 6 ones are, 6 threes are. This will be 140. So B is 140. So the other number is 140.